So actually we try to prove these two. So first I try to prove this one first. Try to prove this one first. So actually we have K equals gamma minus 1 times mc square, E equals gamma mc square, which is the total energy. This is the total energy. E0 is the rest energy. And P is the momentum, which is gamma mv square. So actually we can substitute gamma, P equals gamma mv square here, so that we have gamma mv square. So we have square, and then we have c square, something like this. So next we try to substitute gamma equals 1 over this Lorentz factor. So gamma square will be nothing but this will become c square minus b square under c square, something like that, because we have c square the denominator of the denominator. So we have c square minus b square here, and then c square, and flip it up. It will look like this. So we can substitute gamma square into here. So we have m square v square c to the 4th power, because we have a c square here, and over c square minus v square. So this is the left hand side of this equation. And next we have k square plus 2kmc. So k square is gamma minus 1 square m square c to the 4th power, and then 2 gamma minus 1, and then we have mc square, and then we also have mc square here, so we have m square c to the 4th power. So actually we have m square c to the 4th power. We also have c square c to the 4th power. So that the only thing we need to prove is that this part plus this part is this part, right? We can just factor m square c to the 4th power out. So the remaining stuff is gamma minus 1 square, or actually gamma minus 1 factor out, and then gamma minus 1 plus 2. So it becomes m squared c to the 4th power, and then gamma minus 1 times gamma plus 1. So it becomes gamma square plus 1, right? So we can substitute this one here. So it becomes c square m square c to the 4th power, and then this one is c square over c square minus v square minus 1, and then we can make it c square over minus v square over c square minus v square. So this is actually 1. So finally c square minus v square, so it becomes m square v square c to the 4th power over c square minus v square. So actually we prove this one. So yeah. So and then remaining stuff will be very easy. We can just substitute this part into here, because actually we want to prove this one to be E square, so we can just substitute this one here. So it becomes k squared plus 2k mc squared plus mc squared, or quantity squared. So actually this is nothing but a, k is a, k is a, mc squared is b, this is b. So a squared plus 2ab plus b squared. So this is actually k plus mc squared all square. So k is actually gamma minus 1 mc squared plus mc squared all square. So this is gamma minus 1, this is 1, so gamma mc squared square, so it is e square. So actually we prove that. We also prove this one. Any questions? Okay. So actually this triangle, the triangle here is very interesting. It's very interesting. As you know that cosine theta equals beta. Cosine theta equals beta. And beta is actually beta is actually V over C. Is actually V over C. Which means that for that triangle, this is theta, and this is V, this is C. These two, this triangle and this triangle are similar to each other. So this side should be C squared minus E squared, take the square root. Something like that. Okay. So here's a sample problem. So this is the point. Okay. So what is the total energy? Okay, what is the total energy E of a 2.53 mega eV electron? So actually this 2.53 is the kinetic energy. This should be the kinetic energy. Okay, this should be the kinetic energy. So what is the magnitude P of the electron's momentum in the unit of mega eV over c? Mega eV over c. Note that c is the symbol for the speed of light and not itself a unit. Not itself a unit. Okay, so we can calculate part A as E equals mc squared plus k. This is the original one, because k is gamma minus 1 and we mc squared, gamma minus 1 times mc squared. So so for an electron, the m is 9.11 times 10 to minus 31. And then c is 2.998 times 10 to the 8th power, and then take the square. And then we convert it to EV. So we divide it by 1.6 or maybe 1.602 times 10 to minus 19. So this is mc squared and then plus 2.53 times 10 to the 6th power. So the answer will be 3.04 mega eV. So this is very simple. And then the next one, we calculate the momentum. So we have E squared equals PC squared plus MC squared quantity squared. So we can move this term to the left side, and then take the square root and then divide it by C. So finally we have a P equals E squared minus MC squared quantity squared, take the square root, and then over C. So it asks you that you can have the answer in the unit like this, so that we don't need to substitute C into here. We can just make it like this, and then E is 3.04 mega, and then minus MC squared is this one. This one is actually 3.04 minus 2.53, which is you can write it by 3.04 minus 2.53 squared, something like this. So actually it will be 3.00 mega eV over C. So this is part A, this is for part B. So any questions? Very simple sample problem. Special relativity are quite simple as long as you can substitute some number into the simple equation. But maybe the first part will be more non-intuitive because you need to imagine all the time dilation, length contraction, blah 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 blah, which is not trivial at all. But for this case, you only need to distinguish what is the total energy, what is kinetic energy, what is the rest energy. You need to keep those concepts in mind, and it will not be so difficult. So the next sample problem. So the most energetic proton ever detected 最有能量的质子 ever detected in the cosmic ray coming to Earth from space has an astounding kinetic energy. 3.0 times 10 to the 20th power eV. Enough energy to warm a teaspoon water by a few degrees. 可以把一茶匙的水加热几度，但是它只是一个质子哦。What is the proton's Lorentz factor? And the speed. Both relative to the ground-based detected. So usually, maybe 10 to the 6th power is mega, 10 to the 9th power is giga, 10 to the 12th power is tera. So actually, if it is 10 to the 18th power, 10 to the 18th power, you seldom see this one. But actually, this is using this coaxa. But okay. Here it is 10 to the 20th power. Okay, so here we need to calculate the Lorentz factor. So actually, A equals for part A. We still use the same equation. E equals gamma minus 1 mc squared plus not actually this. We use K equals this one is enough. K equals this one because we already know the kinetic energy here. We know the kinetic energy here. So actually we can make it gamma equals K over mc squared. We can just divide both sides by mc squared, and then this one and this one cancel, and then we add 1 on the right side, add 1 on the left side, and then this one and this one can be cancelled. Okay, so finally we have gamma equals K over mc squared plus 1. So we can just substitute the number. So we have a 3.0 times 10 to the 20th power EV. And then for proton, the mass is 1.67 times 10 to the minus 27 power. And then c squared is 2.998 times 10 to the 8th power square. And then this one over 1.6 times 10 to minus 19. This one is longer. This is plus 1. So gamma is very, very large, which is 3.2 times 10 to the 11th power. Extremely large. So this is the Lorentz factor. And actually, if you use the equation, something like gamma equals 1 over square root of this one, and actually you will calculate that V is actually C. V is actually C because you take the square and then inverse it. So it will be 1 minus something times 10 to the minus 20 something power, which is actually 1. So we try to make this one, actually we try to find the difference between this V and the C by some approximation. So actually, we use R gamma equals 1 over square root of 1 minus beta squared, and then it will be 1 plus beta times 1 minus beta. So it is approximately 2 times 1 minus beta. Because beta is very close to 1. Beta is very close to 1. So we can make this 1 plus beta is close to 2. And 1 minus beta is close to 0. So we only make this approximation for 1 minus beta. We only simplify the 1 plus beta term because 2 and 1.9999 is similar, but 0 and 0.0001 is quite a lot different, especially in the denominator. So we make this approximation, and then next we can square both sides, so we can we eliminate the square root, and then we can move this one to the left side, move this one to the right side, and then we try to solve beta. So finally it will become 1 minus beta equals 1 over 2 gamma square. And then it is actually 2 times 3.2 times 10 to the 11th power square. So this one is 5 times 10 to minus 24, which means that beta is 1 minus 5 times 10 to minus 24. Actually, you can write it as 0.99999, 23 of 9, and then followed by a 5. So finally, we know that beta equals V over C, which means that V equals beta C, which is 1 minus 5 times 10 to minus 24 C. Any questions? Okay, we still have part B and part C. So here we suppose that the proton travel along the diameter of the Milky Way， 就是穿越银河系的直径，就是9.8乘以10的4次方光年，就是98000光年。Approximately how long does the proton take to travel the diameter as measured from the common reference frame to the of Earth and the galaxy? How long does the trip take as measured in the reference frame of the proton? 所以这个例题蛮有趣的。它一开始我们讲一些速度很快的东西，然后讲一些星球大战啊，什么星际旅行啊，然后后面就会讲到一些粒子的，然后这个就是从粒子讲到那个宇宙的尺度，就蛮有趣的。因为你如果关心一些科学的新闻，他们研究宇宙学的话，他们还是要看一些很微小的粒子，什么叫中微子之类的。一些粒子去看一些星球到底发生什么事情，或者 看这个整个宇宙发生什么事情。所以是从最小的东西看一个最大的尺度。OK， 所以这个是说这个质子啊，如果穿越银河系的话，他们在2个坐标系上面各花了多少时间吧？对 ，how long 吧 ，how long， 各花了多少时间？ So actually, we also need to use the concept about the proper time, the time dilation. So for part B, for part B, this one is about is at the reference frame from the Earth. So relatively station. So actually we need to use the delayed time, rather than the proper time, because actually suppose this is the Milky Way, this is the 银河系啊，那它要从这里跑到那里去。那可能地球我也不知道在银河系的哪里了，反正假如说在某个地方，那等于说我们需要一个 clock 在这里，需要另外一个 clock 在那里，它们是同步的，虽然不知道怎么同步然后，所以我们看这个时间的时候啊，就是一个 delayed time。So actually, this is the distance. This is the distance. 9.8 times 10 to the 4th power times c. This is the distance, right? Light year. And then divided by almost. The v is actually very close to c. So this delayed time is 9.8 times 10 to the 4th year. 需要98000年了，就是98000光年，那需要98000年才能够从这里跑到那里去。So the second question is, how long does the trip take as measured in the reference frame of the proton? So this one we need to consider the proper time in the reference frame of the proton, which means that we have a delta t0 equals delta t over gamma. If you still remember this equation. So in the last page, we know that gamma is this one. 3.2 times 10 to the 11th power. So this is a 9.8 times 10 to the 4th power over 3.2 times 10 to the 11th power, which is 3.06 times 10 to the minus 7 year. Or we can still further multiply it by 3060 seconds per hour. And then we have 20 hours per day. And then we have 365.25 days per year, approximately. So after making this conversion, we know that it takes 9.66 seconds for that proton. So this is another extreme case for the twin paradox. So it only takes us 9.66 seconds to cross over the Milky Way, But if we are just at the Earth, we feel that it takes 9.8, 98,000 years to go through. Any questions? If no, let's have a 15 minutes break.